Welcome back to my channel. Today I will be continuing with the second part of enzymes, that is classification of enzymes. Generally, we add suffix ase to the substrate for the naming of an enzyme. For example, lipase, which acts on lipids, nuclease, which acts on nucleic acid, lactase, which acts on lactose. These are known as trivial names of the enzymes. But these names fail to give us the complete information of the enzyme reaction. For example, the type of reaction, cofactor requirements, etc. but which are essential for us to know. So for this reason only, the International Union of Biochemistry appointed an enzyme commission in 1961 for the classification and nomenclature of the enzymes. This came into action in 1964. According to this, enzymes are divided into 6 major classes. The first one among them is Oxidoreductase. Oxidoreductase is an enzyme that catalyzes oxidation reduction reaction. This takes place by the removal of hydrogen from A, which is being added to B. Here, this is being oxidized to A and B is being reduced to BH2. And this is catalyzed by oxidoreductase enzyme. Example of oxidoreductase is alcohol dehydrogenase. Second one is transferase. This enzyme catalyzes the transfer of functional group. For example, methyl group, hydroxymethyl group, phosphate group, etc. In this, X is attached to A. After the reaction, it is transferred to B. This reaction is catalyzed by transferase. Example of transferase is hexokinases. Next comes the hydrolases. Hydrolases enzymes that brings about hydrolysis of various compounds. Generally, it breaks the bond with the addition of hydrogen molecule or water molecules, like this. This is the reaction catalyzed. Example of hydrolysis are lipases. Next one is ligases. In this type of reaction, the enzymes are specialized in addition or removal of groups like ammonia, carbon dioxide, and etc. This catalyzes non-hydrolytic removal of groups from substrate, leaving a double bond sometimes. For example, decarboxylase, pyruvate decarboxylase, deaminases, histidine decarboxylases, etc. Next comes the isomerase. The enzymes involved in isomerization reaction. Generally, this enzymes catalyzes the interconversion of optical, geometrical, or positional isomers by intermolecular rearrangement of atoms or groups. For example, cis-trans isomerase, triphosphate isomerase, and the last one is ligases. enzymes catalyzing the synthetic reaction. This means actually ligase comes from ligate, which means to bind. This enzymes catalyzes the synthesis of new bonds by linking together of two compounds with the breakdown of phosphate bond in ATP. ATP is adenosine triphosphate, which is broken down and forms ADP, and a inorganic phosphate is given. This generally joins two compounds. A is a compound and B is a compound, and it joins to form a single compound, that is AB. Now the example of ligase is glutamine synthase. According to the Enzyme Commission, a 4-digit enzyme commission number is assigned to each enzyme. Now the first digit represents the class. Second digit represents the subclass. The third digit represents the subclass, and the fourth digit represents the individual enzyme. For example, alcohol dehydrogenase. This is the 4-digit enzyme commission number for alcohol dehydrogenase. It is actually alcohol NAD plus Oxidoreductase EC.1.1.1.1. Thank you for viewing this.